Hello, in this video we are going to see the Keysian multiplier. In the previous video we assumed that there was no leakage in this circulation of money. In this video we are going to assume that there is a leakage, which means that every time that people receive money, only part of this money will go to consumption. Okay, let's get started. Let's suppose that there is a consumer that pay $1 for an orange. We are going to denote this quantity C0, and this dollar get into the pocket of somebody. Now let's assume that 20% of this money, which is 20 cents, go to the money pig, and the remaining we can say to the pig. Is that saving? This is something that we are going to see later. So 20% go to the pig, and the remaining 80%, which is 80 cents, go to consumption. And we are going to denote this quantity with the letter C. So this guy buys something for 80 cents, and this money pass through the cashier and end up in the pocket of somebody else. And now 20% of these 80 cents go to the pig, and the remaining 80% goes to consumption, and this money get into the pocket of somebody, and so on. As we did in the previous video, we are going to call income, and we are going to use the letter Y to represent the sum of all of this quantity, which is all of the money that get into pockets, which is this plus this plus this, etc. And the aggregate expenditure that we have before is going to be now the sum of 1 plus this plus this plus this, etc. Everything that passed through the cashier. So what we want to know is what is the relationship between these two constants and these two variables. So we are going to represent income in the horizontal accent Y, and we are going to represent in the vertical axis aggregate expenditure, everything that passes through the cashier, and this 45-degree line represent the point in which income is equal to aggregate expenditure. So we assume that we have an initial consumption of $1, which is the initial contribution to the aggregate expenditure. This dollar come into the pocket of somebody, and these guys put 20% into the money pig, and 80% that we are going to that we use already the letter C goes to consumption, so passes through the cashier. So these 80 cents go to the pocket of somebody else, and so on, and this process goes on. So now we are going to see that this is the expression for aggregate expenditure, because we have the initial consumption, which is $1, this $1, plus 0.8, which is C, this one, plus 0.64, which is this quantity square, 0.8 square, plus this quantity, etc. And this is a geometric series that converges to this value. And as C is 0.8 in this example, then this number is 5. The aggregate expenditure in this example is 5. So if income is equal to the aggregate expenditure, then both values are 5. And as we explained in previous video, if this happens, then we say that the goods and services market is an equilibrium. So aggregate expenditure is 5, which is this initial consumption plus all of the red vertical lines, which is the induced consumption, induced by this initial consumption. So this is 5. And in equilibrium, this 5 is equal to income, which is also 5, which is this. Now, where this expression come from? If we define that aggregate expenditure is equal to this expression, as many authors do, this is what is called the consumption function, then we can say that in equilibrium, aggregate expenditure, which is this, is equal to income. So out of this equality, we can actually deduce this result, this expression. The only thing that we have to do is to isolate C0 first, and then we take y as a common factor, and then we isolate y, and then we get this result, and as C0 is equal to 1, then we have 1 divided by 1 minus c, which is this. So we get this expression for y, but in equilibrium y is equal to aggregate expenditure, so we were able to infer that. But actually it is not really necessary to define this. We can also prove mathematically that this expression is 1 divided by 1 minus c, and we can prove this. We're going to do it intuitively and formally soon, maybe in a couple of weeks or something. We can prove it formally using the concept of limit, and then we can use this result and we can go backward and we can prove actually that by using this result. So in a couple of weeks or months I will put the link of this proof right here. Another thing that I am going to make a video in about 1 month or so, I guess, is that this initial injection of money, that in this case is consumption, it's called autonomous consumption, but we will see that this could be something different, including government expenditure, net exports, etc. We are going to prove that this initial injection of money is always equal to this leakage. So it does saving all of the leakage, all of the money that go to the money pig. We will see. So that's it. See you in the next video.